Hey guys, we're going to do our second video for Unit 7. So this is area and perimeter on a grid. You may want a highlighter or a darker colored pencil for some shading in. So first of all, do you remember how to find the distance between 2 points on a grid? So if you plot 2 points on a grid, we're going to use Pythagorean theorem. A squared plus b squared equals c squared. And then just remember, you're going to count the boxes, you're going to make a triangle, you're going to count the boxes, and you're going to plug it in to find it. So this is very similar. So area and perimeter of the rectangle for number 1. So perimeter is easy, okay, right? Perimeter, we just have to count some boxes. 1, 2, 3, 4, 5 here, 5 here, 3, and 3. So nice and easy. Right now we can see the perimeter is 16. Area of a rectangle is base times height, so this area is equal to 15. All right, now for the next one is, so for number 2, now we're going to find the area and perimeter of this triangle. Okay, not as easy this time. Let's start with the area, because I think that one's a little bit easier. The area of a triangle is 1/2 base times height. Now remember, the base and height are always perpendicular. So the base, 1, 2, 3, 4, 5, 6, 7, 8. The height is actually going to be from A straight down perpendicular, which is going to give 4. So now I can actually sub in 1/2 4 times 8, plug that in our calculator to get 16. The perimeter for this one is a little bit more difficult, because this is 8. Okay, so that's fine, that's 8. So I have to do 8 plus, but notice these two sides are diagonal lines. We cannot just count the boxes. So what we're going to do is we're going to create a triangle from A to B, and I'm going to count those boxes. 1, 2, 3, 4, and 1, 2. And then I'm just going to do my A squared plus B squared equals C squared down here. 4 squared plus 2 squared is 20. So that means C is equal to the square root of 20. And you can do a decimal if you want to. I'm just going to leave it as the square root of 20. So I'm going to put the square root of 20 up here. Then I'm going to do the same thing from A to C. And I'm going to count those boxes, 6 and 4. So I'm going to have 6 squared plus 4 squared is equal to C squared. This is 52. Which means C is equal to the square root of 52. And I'm going to put that on my picture, and I'm going to put it over here. Then, guys, you just plug this right in your calculator. 8 plus the square root of 20 plus the square root of 52. It does say to the nearest tenth, so you're going to get a perimeter of 19.7. Okay? All right. Now, what if it's not easy to identify all of the lengths? Like, what if we can't count them all? Kind of how we just did there. There's an easier way to do this. We're going to inscribe the shape using a rectangle. So hopefully you can see this color. So basically what we're going to do is, when you look at this picture right here, you cannot count any of these sides. Okay? It's not going to happen. You can't count a base, a height. Okay? You're not going to be able to do it. So what you're going to do is you're going to make a box around the shape. So that means I'm going to basically be connecting all of my points to form a box like this. Okay? I write to shade or highlight the region you want to find the area of. That's completely up to you. So basically, we want to find the area of this. So going back to the lesson that we just did, it was the area of the shaded region. So what you're going to notice when we box in the figure, we create triangles. There's one triangle here, one triangle here, and one triangle here. And they're right triangles, so we can easily do the area. So here's how this works. First, we're going to find the area of the entire box that we drew. So this box is currently 3 by 6. So the area of the box is equal to 18. Then I'm going to number the triangles. So I'm going to call this one triangle 1, this one triangle 2, this one triangle 3. And it doesn't matter what you label as what, okay? So we're going to find the area of all of these things. So remember, the area of a triangle is equal to 1/2 base times height. Well, we drew these triangles, and look, the base of this one is 1, 2, 3, 4, 5, and the height is 3. So it's 1/2 of 15, which is 7.5. Then I'm going to go to 2. You look at 2, it has a base of 1, 2, 3, 4, 5, 6, and a height of 1. So it's 1/2 of 6 times 1, which is 3. And then going down to this one here, base of 1, height of 2. So that's going to be 1/2 of 2, which is 1. Okay, the whole point is this. We only care about the shaded. We don't care about this non-shaded stuff. So if we add all of these together, 7.5 plus 3 is 10.5 plus 1 is 11.5. So if the entire box is 18 and this non-shaded stuff is 11.5, the area of that triangle, which is ABC, can simply be found by doing 18 minus 11.5, giving us an answer of 6.5. A little tedious and a little bit more work, but it's not hard work. So your final answer for that one is 6.5. Okay? All right, so now we're going to try the next one. The next one is the quadrilateral. So we have quadrilateral ABCD now. Okay, so same thing. First we're going to start by boxing it in. So this one's a little bit different because it has 4 sides. So actually when we box it in, because 2 of the sides are luckily vertical, that makes it easier for us. So I'm finding the area of this whole shape right here. So I really only have 1 triangle here and 2 triangle there. So first I'm going to do the area of the box. So that box, if we count, is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So that whole box is 8 times 5. So that gives us 40. Then we're going to do the area of each triangle separately. This triangle, remember triangles 1/2 base times height. 1, 2, 3, 4, 5 for the base, 1, 2, 3 for the height. So 5 times 3, 1/2 of 15 is 7.5. And then we're going to do the area of 2. It's 1/2 of 5 times 1 if you count. 1/2 of 5 is 2.5. So we add this up, we get 10. So that means the area of ABCD would have to be equal to 30. We'll take the entire box of 40, we'll minus out the non-shaded, which we did in last lesson, to get a 30. Okay, I'm just going to do one more. So one more is just a rectangle. So what's nice about this rectangle is when we box it in, okay, because it's a rectangle, and if we were to number these, 1, 2, 3, 4, it never really matters what you number what. So if we were to number these, we're going to do the entire box first, which is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's going to be a 5 by 5, which is 25. So here's what's nice. When you do the area of the first one, 1/2 base times height, it's 2 and 2, so it's 1/2, 2 times 2, which gives us 2. If you look, I'm going to jump to 3. 1 and 3 are the same exact thing. And that will always happen if it's a rectangle. So I'm just going to save myself some work. Then I'm going to go to area of 2. 1/2 of 3 times 3 is 4.5. And then if you notice, 4 and 2 are the same. So that's going to be 4.5. So we're going to add those all up to get 13. So that means the area of the rectangle, which actually doesn't have any labels, is going to be 25 minus 13. So that is going to give you 12. Okay, so what you can do is I would pause it now and try the 3 practice ones. And then when you're ready, unpause it, and then I'm going to show the entire, I'll show the answers to the practice page. So here are the answers to the practice page. So there's the first one. Number 1 is 29. Okay, if you look at the second one, and the third one,